discussing first derivatives. Consider the function f of x equals 4x to the power of 4 plus 2x to the power of 3 minus x squared. We need to determine the intervals of increase and decrease, and we do so through the first derivative. F prime of x is equal to 16x cubed plus 6x squared minus 2x. Factoring, we get 2x times 8x squared plus 3x minus 1. We need to determine the x-intercepts, where y is equal to 0. Setting the first derivative to 0, we see that we have an x-intercept of x equals 0, and since we cannot factor what's inside of the second bracket, we use the quadratic formula. X equals negative 3 plus minus root of 3 squared minus 4 times 8 times negative 1, all over 2 times 8. This evaluates to be negative 3 plus minus root 41 over 16, and we get that our other two x-intercepts are approximately 0.21269 and negative 0.58769. We draw a table like so with our various intervals. We have negative infinity to negative 0.58 and so on. Then we leave a spot for negative 0.5876 and so on. Our next interval is negative 0.5876 to 0. Then we have 0, 0 to 0.21 and so on. And then we will have a spot for 0.21 and then 0.21269 to infinity. And we leave spots for f prime of x and f of x as well. We need to determine whether f prime of x is positive or negative inside each interval. Let us choose negative 1, which is within the interval on the very left. We substitute the values of negative 1 and we get that it is negative 8. And so we show a negative sign. Then we have that f prime of x is 0 at all of our x-intercepts, and we move on to the next interval. If we choose negative 0.2, we have that f prime of negative 0.2 is 0.512, which is positive, and so we place a positive sign. Moving on to our next interval, we choose 0.1, and we see that f prime at 0.1 is equal to negative 0.124, which is negative, and so we place a negative sign. For our final interval, we will choose 1, and so we have that f prime at 1 is equal to 20, which is positive, and so we place a positive sign. The final thing that we need to do is to determine the intervals of increase and decrease. Wherever f prime at x is negative, that means that f of x is decreasing. Similarly, wherever f prime of x is positive, we have that f of x is increasing. And we show this through arrows in our table. And so finally we can determine that the intervals of increase of f of x are negative 3 minus root 41 over 16 to 0, and negative 3 plus root 41 over 16 to infinity. And the intervals of decrease are negative infinity to negative 3 minus root 41 over 16, and 0 to negative 3 plus root 41 over 16. It is proper practice to include exact numbers within our intervals to minimize error, and so that is important to keep in mind for future questions. For more information about the first derivative, please refer to our library guides.